Okay, let's talk about vectors. Okay, vectors and scalars. Okay, so in physics, vectors and scalars are a big deal because we deal a lot with vectors because vectors are quantities that you can break down in 2, 3, or 4 or more dimensions. Okay, so the quantities that you have in physics could be vectors. Okay, you can have vectors or you can have scalars. And vectors, you can represent them with a little arrow here. And this would be the magnitude. The magnitude, well, the size of the vector could be a representation of the magnitude. This could be, for example, 5 meters per second vector, a velocity vector. And you can represent the direction of your vector with the angle. For example, if this one is 45 degrees, well, that would be the direction of your vector, okay, respect to the floor here. So quantities, we say that we have vectors and scalars. So what are vectors? Vectors could be displacement, okay, displacement. Displacement is a vector. We can use this one for displacements. Velocity, okay. Velocity is a vector, delta V, and we put the little hat to indicate that we're talking about the vector. Acceleration. Acceleration is a vector. So we got the little hat of a vector. Force, okay, force is a vector. And we could put the little hat there. So we got all these are vectors. And what is the thing with these guys? Well, you can break them down in components in 3 dimensions or more dimensions. And then we got scalars. Now, scalars are quantities that you cannot break down in components. And who are the scalars? Well, it could be the energy. Energy is a scalar because you can have 10 joules. We'll see about that later, the units. You get 35 joules, okay. Another one, another quantity that you can say is a scalar would be mass. You can have 35 kilograms of something or 45 kilograms of something. And that would be a scalar quantity. You don't have to break it down in components in the X direction or the Y direction. The same with energy. You don't have to break these guys down. So these are scalars. Another scalar would be volume. Okay. You can have 5 cubic meters, for example. If you have like a little box like there. And volume is a scalar. You don't have to break it down in other components. Electric charge, okay. Electric charge, you have 5 coulombs, 10 coulombs. And that's another quantity that you can say is a scalar. So we have vectors and scalars. Those are the 2 most important types of quantities that you're going to play around when you do physics. And let's do an example here. Okay, let me get to another board. Let's see. So let's suppose that we have a reference frame. Here is your reference frame. And in this reference frame, you're going to have a little vector here. So let's put a little vector right here. And you have a vector that comes this way. Okay, let's do it a little more from the origin. And here is your vector. Okay. And let's say that this little arrow represents a vector that is 5 meters per second. And then you have your angle here. Let's say this is the angle theta and it's 45 degrees. And this is going to be the x-axis, and this is going to be the y-axis over here. And this quantity is going to be a vector. That's why we have the little hat over here, the little hat that tells you this is a vector. And the good thing about this vector is that you can break it down into components. One component is going to go on the x direction, and the other component is going to go on the y direction. And how can we get those components? Well, we have our formulas. We'll talk about them in another video. Vx, which is the component in the x direction, is going to be the magnitude of your vector. And let's put these two representations for the magnitude times the cosine of theta. And the vector in the y direction is going to be the magnitude times the sine of theta. So these two formulas are going to give you the components of your vector. So this vector, which is this one right here, is going to be broken down into components. We're going to break it down into components. So let's do the first one. So what do we have? Let's use another color here. Let's use the blue. So Vx is going to be, the magnitude is going to be 5 meters per second. And we're going to multiply that times the cosine of 45 degrees. So that's going to be 5 meters per second times the cosine of 45 is going to be square root of 2 divided by 2. And if you do the math here, it's going to throw you 3.54 meters per second. Let's not forget the units, because this is a velocity vector. And the component in the y direction is going to be the magnitude. And here is the magnitude, which is going to be 5 meters per second. And it's going to be times the sine of 45 degrees. And the 45 degrees are going to give you the direction of your vector. So this vector, we can say, has a direction of 45 degrees respect to the x-axis. And that's how you get the direction of your vector. So this is going to be 5 meters per second times the sine of 45 is going to be square root of 2 over 2. And if you do the math, you get the same number, 3.54 meters per second. So now you have your two components of your vector. Let's say that it's going to be this component right here, which is going to be v in the x direction. And you got your little vector there. That's the hat for the vector. And then you have your other component, which goes this way, which is going to be this one here. And this is going to be v vector in the y direction. And this one is going to be 3.54. This one is 3.54 meters per second. And this one, v in the x direction, is going to be 3.54 meters per second. So now you have your components. You have your two components for your vector. You have the component in the x direction, and you have the component in the y direction. So you have broken down your vector in two components, one in the x direction, one in the y direction. And that is the good thing about vectors. You can break the vector down in 2 or 3 or sometimes more components, you know, in other subjects. And if you do more complicated math, you can break it down in more components. But for physics, we're going to stay here. So here we go. And what happens if you have another one? Well, let's say let's see what happens if you have another one. I'll put it over here. Let's say you have two of these guys. Let's say here is the original one. This is going to be 5 meters per second. And then let's say you have another one over here and another vector, which is 5 meters per second. and this is 45 degrees, and this is 45 degrees too. Well, what do you have here? Well, we already did the first one. Let's call it VA, and let's call this V vector B. But what happens here is that the components of the first one, which this one here, this is V in the X direction. And then you got another component here, which is V in the Y direction. And we have those already. You have obtained those at 3.54. What about the other guy? Well, the other vector is going to have another one that goes this way. Okay, and another one that goes this way. So I'll put it over here. I'll put it on top of this one over here. See, you can do that. You can move it around as long as it stays with the same magnitude and the same direction. So what can you do? Well, these guys are going to cancel out. This one is going to cancel out with this one because they have the same magnitude and they're pointing in opposite directions. So they're going to cancel out because they have the same magnitude. But what about the other guys? The ones that go in the Y direction, you're going to add them up. So it's going to be the red one plus the green one. So the total vector is going to be V in the Y direction. Let me do it a little better here. So it's going to be VA in the Y direction plus VB in the Y direction. And that's those components are going to be 3.54 meters per second plus 3.54 meters per second. And this is going to throw you 3 is going to be 6, is going to be 7. Okay, 7.08 meters per second. And that is the summation of the vectors, because if you want to add up the vectors, they have to be in the same direction. And it happens that the red guy here and the green guy here, they have the same direction, so you can add them up. What about the other guys? The ones that go in the X direction? Well, those are in the same direction, but they're pointing in opposite ways. So they're going to cancel out. And there you go. So that's how you play around with vectors. But there's many other cases, and we'll look at more cases in other videos. Okay, so we'll stop this one here and we'll do more examples. Thank you. Bye.